All right, here we go. We're going to talk about slope. So when we're trying to calculate slope, we need to figure out the change in the y over the change in the run. So you may have heard it as rise over run. So rise is the up and down, run is the left and right. So in order to figure out the change of the rise, we're taking the difference between the y values divided by the difference of the x values. So here I've written y2 minus y1 equals x2 over x2 minus x1. Okay, and it doesn't matter if I call this one x2, y2, or if I call this x1, y1, as long as I don't call this one x1 and not y2, because then we'd have the opposite sign. So let's do some examples. Okay, so here I've made this y1 and I've made this x1, and then that's where these values here come from, and I've got x2 and y2. So we're going to do this 0 minus 6 in the numerator and 12 minus 0 in the denominator. That gives us the difference of the in the x direction. The yellow part gives me the difference in the y direction, and there's our slope. So if the line goes down as we go to the right, it's got a negative slope, and here our slope is negative 1/2. Here I take the difference of the y values, 1 minus negative 1, and 5 minus 0, and I'm going to end up with a positive slope of 2/5. Hit pause if you need to look at this some more. Okay, now in this example, determine the slope of the horizontal line that passes through D 1, 2. So 1, 2 is right there. Horizontal line is going to have a slope of 0. So when we're dealing with slope, it's important we're going to be using a lowercase m. The reason that's important is because we're going to be using a capital M for coordinates of the midpoint. So whenever we're using slope, lowercase for slope. Okay, just for reference. Okay. All right. Now show that the gradient of the vertical line passes through this point is undefined. So when you show something, that means you need to have some mathematical explanation. So I just picked some random point above 1, 2 to create a vertical line. And if I do y2 minus y1, 4 minus 2 in the numerator, and the difference of 1 minus 1, that's going to give me 0 in the denominator, and so that's going to give us an undefined slope. So like I said, if I'm showing, I just picked some random point above that. Okay, so it's undefined because I have 0 in the denominator. Okay, so in this one here, we have these 2 points, and we calculated the slope. Negative 5 minus negative 11 is going to give us positive 6, and 0 minus negative 2 is going to give me positive 2. All right. Okay, so let's look at this next one here. Okay, so here we've got y2 minus y1 over x2 minus x1, and this one's a little different because they've given you the slope is 0.6, so I know m already. Okay, and one of the coordinates is 30, 60, and the other coordinate is 230 comma h. So I said that this was x1 and this is y1. Or let's see, what did I do? Actually, x2, y2 is what I did, but it really doesn't matter as long as you follow the same process. And here our y1 is h and our x1 is this. So the first thing I did, okay, so I did 30 minus 230 is going to give me negative 200. And then in order to solve for h here, I multiply negative 200 on both sides. Negative 200 times 0.6 is going to give me negative 800. Then we add 60 on both sides. Oh, wait, sorry. If I multiply negative 200 on both sides, I get negative 120 equals 60 minus h. So then I subtract 60 on both sides, we get this. And so then positive h is equal to 180 meters. Okay. So here, ignore this blue line. That was a mistake. So I just used the slope formula to figure out each of these here. So y4 minus 3 in the numerator, negative 1 minus 2 in the denominator. So if you've made an error here, you probably made a sign error. So check your work. Hit pause and check your work. Okay, on the graph below, graph a straight line of 0, 0, and negative 5, 6. There we did. And passing through these 2 points, so negative 1, 2 is right there, and negative 3, negative 5 is right here. So I drew a line between these 2 points. So the orange line is the answer here. Okay, now we're going to talk about point slope form or point gradient form. So it's written like as this: y minus y1 equals m times x minus x1. And how do we get this formula? Basically, if I use my slope formula and I multiply x minus x1 on both sides of the equation, then I'm going to have x minus x1 times m, and then nothing in the denominator here. So basically, I took this formula here, I multiplied x minus x1 on both sides of the equation to get this formula. And anyways, this formula is in your IB formula packet, and it's right here. Okay, so it's called point slope form, or they like to call it, gradient slope form, or no, point gradient form. Sorry, they like to call it point gradient form. Anyways, okay, and then there's also something called standard form, which is ax plus by plus c equals 0, and a, b, and c have to be real numbers. So whenever you see this funny-looking r, this means real numbers, and this funny-looking e kind of symbol means an element of real numbers. So, and here we've got the same formula here. Okay, here they wrote it plus c, here they wrote it plus d, but notice those values, that's a constant without a variable x or y. Okay, we're going to be using these formulas in just a minute. Okay, if I've got a horizontal line, there is no change of the x value. There's no x value because no matter what x is, y is always going to be 2. And for a vertical line, it's going to be, the equation is going to be x equals the number, because the y, no matter what y is going to be, x has to be 3. Okay, let's look at this example 11 here. Okay, so find the equation of the line that has a slope of 3 and passes through this point. Okay, so the first thing I did was I put this into point slope form. This is that equation that we just saw on the previous page in point point slope form or point gradient form. So my y1 is 7, my x1 is 1, my slope is 3, so I put the 7 and the 1 and the 3 into this equation, and there's my equation of the line that passes through 1, 3 and 2, 5. So the first thing I did is I did in the numerator 5 minus 3, in the denominator 2 minus 1, and I figure out my slope is 2. And then I could, if I'm putting it into point slope form, I simply plug in one of those points, the 1 and the 3, or I could plug in the 2 and the 5. Okay. If I wanted to put this into standard form, then let's look at this one. I'll just do this pink one here. If I'm putting it into standard form, I do distributive property with the 3. I get y minus 7 equals 3x minus 3. I could subtract 4 on both add 7 on both sides, and then I get y equals 3x plus 4. This is slope-intercept form. And I guess we didn't talk about that yet. We'll talk about that in a few seconds. And if I bring the 3x, if I subtract 3x on both sides, I have negative 3x plus y. And if I subtract 4 on both sides, I get minus 4 equals 0. All I've done, and then this gives me standard form. All I've done is I've moved the 3x to the other side of the equal sign and changed the sign. I've moved the 4 to the other side of the equal sign and changed the sign. And they may ask you on the IB test to write your equation of the straight line in either one of these forms. So here's my equation in point slope form. Here's my equation in slope-intercept form, and here's my equation in standard form. Okay, question 13. Here we've got an equation. They've given me a point, and they've given me 2 points here, and they want to see if this point is on the boundary line. So the first thing I do is I wrote the equation. So there was a couple ways I could have done this. I could have seen if from looking at this, I could say, okay, look, it goes up to and over 6, so my rise over run, my slope is 1/3. It looks like my y-intercept is 6, so my equation is y equals 1/3 x plus 6 because it's in slope-intercept form. We haven't really talked about the yet, though we can talk about that in just a minute, but you may have remembered this from your Algebra 1, Algebra 2 days, and then to see if this point fits in, we plug in the 25 in place of x and the 30 in place of y, and then we see that they're not equal, so this means the tree is not on the boundary line. Now using the point slope form equation, that's another way to do it. Once again, you look at this and you can see that the slope is 1/3, and I just pick a random point, 6, 8, so I put the 6 here and the 8 here. I could do distributive property with the I plug in the 25 and the 30 in for x and y, and then I do 25 minus 6, I get 19, and once again, these are not equal to each other, so point C is not on the boundary line. If these were equal to each other, then it would be on the boundary line. You might want to hit pause to think about that. Okay. Next one. Okay, so now we're talking about slope-intercept form, which is what you're more familiar with from Algebra 1 and Algebra 2. Okay, this m value here is my slope. This value here is the y-intercept, which is when the y-intercept is when x is 0. Okay, so we've started off with our equations in point-slope form, and they want us to change it into standard form and find the x-intercept and the y-intercept. So the first thing I did was I did distributive property with 3, and then to put it into standard form, I added 3 on both sides and subtracted 3x on both sides. This is the same as what we did up there, isn't it? Okay, and then if I kept everything on, if I kept the 3x and added 7 on both sides, my equation would look like this. We just talked about this up above. Now, the y-intercept, if I've got this in slope-intercept form, when x is 0, that gives me the y-intercept. So if I plug 0 in here, my y-intercept is 4. Now to find the x-intercept, we have to make y equal to 0. So let's just take one of these equations. If I make y equal to 0, then I have 0 equals 3x plus 4, and we subtract 4 on both sides, divide by 3, and my x-intercept is negative 4/3. Now, same process. If I want to put this into slope-intercept form, I just distributive property with the 2, and I add 3 on both sides, and here's my equation here in slope-intercept form. If I want to put it in standard form, I subtract 2x on both sides, I subtract 1 on both sides, and here's my equation in standard form. If I want to find the y-intercept, I can look at slope-intercept form, and there's my y-intercept. When I make x equal to 0, y is only going to be equal to 1. If I take one of these equations, I want to find the x-intercept, that means I have to make y equal to 0. Let's see if I pick this equation at random. I can make y equal to 0, and then I can solve for x. So we subtract 1 on both sides, divide by 2, and here's my x-intercept. You might want to hit replay and watch this again if you need help finding these things. Okay. Last page. Okay, so they've given me a slope, they've given me a point. The first thing I did is I put in the points and the slope into point-slope form. Okay, next thing I did is I did distributive property with a 3. I added the 4 on both sides, so 4 plus negative 3 gives me 1, and now I've got my equation in slope-intercept form. Now to put it in the standard form, I bring the 3x to the other side, change the sign. I bring the 1 to the other side, change the sign, and now I've got it in standard form. To find the y-intercept, I make x equal to 0 using this equation. I end up with y equals 1. If I want to find the x-intercept, I make y equal to 0, and then so I've got 0 equals 3x plus 1, subtract 1 on both sides, divide by 3, there's my x-intercept. If I want to graph this, I think the easiest thing to do is plot 1, 4, which is right there. And then if the slope is 3, that means I go up 3 over 1. Or I could go down 3 to the left 1, and then I drew my line. Okay, let's look at this other equation here. Okay, so slope of negative 5 and through this point. So I put the slope there and put the point in, distributive property with the 5, subtract the 4 on both sides, there's my slope-intercept form. If I add 5x to both sides, subtract 31 to both sides, there's my standard form. My y-intercept form is when I make x equal to 0. The x-intercept is when I make y equal to 0, and you might want to hit pause and check your work. Last questions. You may want to hit pause and look at this. Okay, they gave me a slope, they gave me a point, put it in slope-intercept form. Okay, distributive property with the 1/2, and I get this. And if I add 3 on both sides, I get this, and there's my slope-intercept form. Now, if I want to put it in standard form, as you remember on the previous page, it said we need to have integers for a, b, and c. So from this equation right here, if I multiply both sides of the equation by 2, I end up with 2y minus 6 equals minus x minus 1, because I've multiplied this whole equation times 2 so that every coefficient is an integer. Now I add x on both sides, I add 1 on both sides, and now here's my equation in standard form with the leading coefficients as integers. Okay, last question. We've got our slope. We had to figure out the slope given the 2 points. So I figured out the slope, 8 minus 4 in the numerator, 1 minus negative 1 in the denominator. I've got 4 over 2. My slope is 2. Put this into point slope form. Use the slope of 2. And there we go. Did I make a mistake? Oh no, I didn't. So I put the 1 here and I put the 8 here. All right. Hope this helps.